Hi, everyone, and welcome to another episode of the Final Frontier podcast. I'm your host, Daniel Penaranda, and I'm joined with yet another incredible guest today. He is Marc Donato, Vice President of Engineering for the Canadian Space Mining Company, and he has a fascinating background, full of experience, and we're going to cover an amazing topic today. We're going to be covering lunar mining and its potential and applications for the future. So without further ado, Marc Donato, thank you for joining us today.
Thank you.
Before we jump into the topic, why don't you share with us a little bit about your background and what got you started in the space industry?
Well, I live in Montreal, and I went to university at McGill, studying engineering honors. I continued on and did my PhD in combustion physics. So I did work for some years in combustion physics. But I had the opportunity fairly early on to work in space. Canada's premier space company, which was at that time SPAR Aerospace. So I had the opportunity to work there on a project which was very, very interesting, basically to develop an infrared test capability for Canada, satellite test capability. And I jumped onto this opportunity because I was always interested in space. I followed the Apollo program. I had all these NASA roadmaps and plans and different stages of the lunar missions. I got up in the middle of the night to see Neil Armstrong stepping on the moon. So I was always a keen space person. High school, I would do projects on the solar system and all that, but it wasn't clear the path to get there. And when the opportunity presented itself, I jumped onto it. So I worked at SPAR, and I worked at many jobs. I came up a little bit through the rank of project manager and department manager and program manager, director. I became a chief scientist. I became vice president of a business unit, and finally general manager. I was general manager in Montreal for 8 years, but then I was a general manager in other divisions in Toronto and in LA. Typically, I was sent as general manager when the division were in trouble, and Montreal had been losing money for 5 years. Their population had gone down to about 260 people, but within 4 years I had over 900 people there, and I had increased the revenues by one order of magnitude, and most important, I had changed the money losing type of thing to the most profitable division in MDA. So, and in a way, it's not by doing anything extraordinary. It's just by doing what's the right thing and what's the common sense thing. So this people think you have to do incredible things, but if you stick to doing the common sense, the right thing, and you have some vision, then you do progress.
I heard common sense isn't so common anymore.
No, that's true, unfortunately.
And what led you to join the Canadian Space Mining Company?
I had worked for almost 40 years and different space projects, and the space station, rovers to go on Mars. I worked with a lot of interesting people all through the world, and I had retired, but then they came and reached out for me, and at first I probably have the same impression that most of your listeners or viewers have, is that space mining is something for the far in the future and something that they write about in science fiction books and all that. And but I listened to them make sales pitch, so to speak, to me, and I realized how near at hand it is, and how I can contribute to that, and that got me interested. So that's how I wound up in the company.
So I think that's a great lead into the topic today. How far away do you think we are from mining the moon?
Well, we're not that far. I think it's important before we explain that is to understand that there is space exploration is entering a new phase. And okay, the governments are driving this new phase. You got the space station, which is the Lunar Gateway, which is the next generation space station. And it's in orbit around the moon. Well, there's a Lagrangian point near the moon, which is where the kind of gravity of the Earth, the moon, and the sun cancel each other out. So it's an orbit about both, and it's a halo orbit. What's a halo orbit? Well, if you have the moon there and you think of just a halo around it, well, that halo stays constant as the moon moves around the Earth. So that's why they call it a halo orbit. And it's so that space station is going up, right? And people found some water and different things on the south pole of the moon. There's probably the same on the north pole of the moon, but the halo orbit, which is elliptical, does bring you, within 3,000 kilometers of the moon. So there's a project Artemis also started on the moon. It's an international project, just like the space station of basically the U.S. and Europe and Canada, of course, and all of that. And that's the start of the new space exploration. It's going to be establishing, first of all, a space station away from the moon for the first time, and establishing a base on another planet or moon, if you like, for the first time. So this is the new era of space exploration, and that the government is driving. However, there's a whole bunch of things that come along with it, and space, I guess we're just at that time where everything's coming together at the same time, with the launch costs reducing, with a lot of private enterprise going into space. You have Amazon, you have SpaceX, and they say Amazon, they say, they send all these people, but it's their rockets go to space. They just tried it with sending people, so they're all seeing the same thing. I was saying the Lunar Gateway and the moon base, Artemis. So they're all realizing that there's tremendous potential there. There's going to be the shuttle or the space tug or different things to go between here and the Lunar Gateway. There's going to be similarly shuttles going from the Lunar Gateway to the moon surface to the the Lunar Gateway, because it's in a very, very low gravity point, is an ideal point to launch for other space exploration, like going to Mars. When you leave Earth, you have a tremendous gravity well to get up to orbit, and another enormous gravity well to leave orbit to go towards the moon or another planet. Gravity well is pretty good when you're coming in and get captured by it. It's really bad when you're leaving there. And one of the reasons it takes us so long to go to the moon is because we have a limited amount of fuel. By the time we get out of the Earth's gravity well, we used up a tremendous amount of the fuel. So typically, 80% of it or more. So I'm just setting the scene here of what's happening. There are hundreds of companies with different projects, either related to the Deep Space Gateway or to Artemis or to traveling between them. And this is kind of what we can see. And I'm sure there are others. So as part of this new phase, there is an infrastructure. So there's all kinds of people with all kinds of projects. But one of the things, and in fact, the thing that is the most needed with this infrastructure is fuel, okay? And if you had fuel at the gateway, you could refuel in a low gravity spot, your rockets, and you could do the trip to Mars in much shorter time, for example. And it's much more appropriate for astronauts to do the trip in much shorter time, and not 8 months, but 2 months or something like that. So so fuel at the gateway is certainly something that is needed. And there in seminars and talks about the moon, which happens often, which happens with the space agencies and all that, people mention that they if there was fuel, or can we get fuel there? And the main part of the fuel is the oxidizer, or the oxygen. So lunar rock happens to contain about 40% oxygen in the form of oxides, iron oxide, titanium oxide, aluminum oxide. So it is there, if we like, and there are processes, chemical process, to take out oxygen, the oxides out of those metals. We do it all the time on the Earth. We want titanium, we mine titanium oxide and we transform it. We want aluminum, we mine aluminum oxide and we transform it. So the oxygen is there. The processes exist on the Earth. And if we could get oxygen to the fuels, to the space station, it would be a major part, the major part of getting fuel up there. If you have a hydrogen oxygen, well, the hydrogen doesn't weigh much. The oxygen weighs a lot, okay? And some companies said, well, forget about the exact fuel. Get me the oxidizer. I will buy that. So because the moon rock contains so much of it, that's the main number one on the impetus scale. And following that, you have, well, if you have hydrogen, because there's water on the moon, then that is very good. You always need water in space, so that is very good. And then you get all the secondary things. You'll get titanium, aluminum, and all of this will be ready. There's talk of using that for 3D printing, to make parts in space, to make different enclosures or habitats, or all this. So all of these are in the papers today, and all of these have proposed methods to. So space mining is kind of needed, and for this, and for to support the infrastructure. And space mining, I want to say, is just the tip of the iceberg of in situ resource utilization. Exploration of space will come with in situ resource utilization. It makes no sense to bring them out from the Earth, let alone all the energy pollution, maybe, if you call, of launching a rocket and getting such a little fraction of whatever it is you have weight out there. It's to use the resources in situ, and mining is obviously going to be a very, very big part of that. And on the moon, it's ideal. It's lunar dust. It's lunar regolith, which is the surface layer, the unconsolidated lunar rocks and lunar dust that is just there on the moon, and contains all these metals and the oxygen.
Great. And what enabling technologies do you think are lacking to fully facilitate mining on the moon?
Really, all the technologies we want to use exists on the Earth. Okay, so from that point of view, from the very basis point of view, it exists. But to make it work on the moon is a different thing. So we got to adapt it and transform it, the processes, to work on the moon. And the moon is not a very nice place. We have to understand that the moon is, well, first of all, during the day is 130 degrees C, 260 Fs, and during the night is minus 170 C or minus whatever it is, 280, 480 F. So, and the day lasts 14 days, the lunar day, and the lunar night lasts 14 days. People don't realize it because we're on a planet that's spinning, so the moon kind of comes up and down, but you get a new moon every 28 days, and you get a full moon every 28. So it's 14 days from a new moon to a full moon and that's the moon going around the Earth. So there are very big challenges on the moon. There's no air, so you have to account for that. There's no convection. You have to account for that, and you have to account for the temperatures. You have to account for the temperature swings. You have to account for the lunar night. Well, solar cells won't work during the lunar night, so you have to worry about energy and an energy source that would work during the night, or get solar cells and accumulate some of the energy so you can work through the night. Lunar dust is very abrasive, and in fact, there's roughly a 1-year delay in Artemis, mainly because of the lunar suit development, and they spent. I was reading on it, if you believe what you read on the internet, which is always an if, but they spent close to $500 million so far developing that lunar suit, and because they're trying to get a highly mobile thing, and the lunar dust and the joints you would have, there's some challenges there. So definitely, getting the Earth technologies to work on the moon is one challenge. The fact that there won't be human presence that much, and that human presence is more complicated to work on things, that's the second challenge. In fact, there's no air, I mentioned, but there's also getting a system, like a number of mining vehicles working kind of autonomously, and then a process kind of working autonomously. Eventually, that's the goal. And creating a system on another planet or moon has never really been done before. So this is where the challenges lie: the environmental conditions, and creating the fact there's going to be not a lot of human presence or no human presence, and then the fact of creating a system that works outside the Earth. So all of these things are huge challenges.
So there's still a few things to cover before we're there in mining.
Well, I mean, yes, but a lot of people are working on it. All right, and just like our mining, our company intends to partner with different companies. So there are literally hundreds of people, hundreds of companies working on those processes. You need a communication network on the moon, so to communicate between the different rovers. You need a backhaul communication network to send that back to the Earth. Okay, but there are a lot of companies. There's companies working on laser communications. There's companies working on they're talking about, there's a few companies working on a 5G type system for the moon. So we can't possibly do the whole infrastructure ourselves, but we think everybody's kind of pointing and going in that direction at the same time. So we just want to take the partners out there that are going to be doing things that we need, and we want to develop as little as ourselves, by ourselves, and try to use other people's good ideas. And everybody's kind of in the same boat, because the person's figuring out a 5G network for the moon, just say it's going to be needed. There's going to be people up there. There's going to be devices. We have to intercommunicate. So there's a whole kind of population of companies and all that looking at that, and it's to select the right partners in there to kind of help us move along.
So you can't do it alone. There's an African proverb that I like. It says that if you want to move fast, you go alone, but if you want to make it far, you go together.
Yeah.
Yeah, but
So
I correlate with the space industry. Is the space is probably the biggest endurance run you could think of. So to be able to enable those technologies and enable those breakthroughs, we all got to do it together.
and it's by choosing the really good ones, the successors in there, and building upon what they're doing or incorporating their thing, or that you make real progress. So definitely we have to we're part of a community, and we're moving along with our community. We have our vision as to our place and what we want to do in there, but we're not trying to recreate everything. We're just pushing that one idea and using the developments and the good ideas of other people as partners to get to where we want to go.
What effect would mining on the moon have on the moon? I guess you would say environmentally for the moon.
Yeah, environmentally, well, I don't think we'll pollute the air, but first of all, we have to understand the moon's a pretty big place in terms of area. The moon has roughly the same land area as the Earth. How many people are we on Earth? 8 billion or something. So and there's parts of the Earth which are like probably half of the Earth is desert, desert. You can't go there either up north or there are few people there. So it's a really big place, so I think that on a global scale, we don't have to worry so much in certainly in like a reasonable time frame. But however, locally there can be issues, and already people are saying concentrate on the south side of the moon, South Pole, because the North Pole probably has the same thing, but we should only go to one of those places at once because we may discover things. And beyond that, like our company has sustainability objectives, and we plan to not just dump what the slag or the products that are not the main products, but we plan to reuse most of them. So we certainly agree with that angle, and certainly locally you don't want to create local pollution, if you like, in the wide sense of the word, around the moon base or around things like that. So we certainly have a policy of sustainability there.
Great. Yeah, I try to imagine on how the dust kick-up would it physically react in that sense.
Yeah, yes, we're just starting on the dust management side of things. There's some talks of creating some kind of roads, but you can see that if you wind up with a lot of aluminum out of processing oxygen, you can use a very there are a number of techniques that have been developed for 3D printing on the moon, and you can just just whip out some sheets of it, and maybe that we still haven't gotten to get a real handle on dust management, and part of this will be iterative, and we'll see just what kind of problems we come out with, and we'll address them as we go. But I'm talking for us, our idea of sustainability and being able to produce things other than oxygen on the moon certainly could help there. But it's going to be a problem facing the whole world community that's going up there, and we'll have to find solutions, management solutions. We'll have to kind of attack the problems when they show up, different facets of this the moon dust problem.
Great. And you're the current VP of Engineering for a Canadian space mining company. Can you share with us a little bit more about the company and its initiatives?
Well, in part, Canada has always been a leading country in space, very, very close behind the US, sometimes, number 2 behind the US. We were talking a little bit before how, in 1958, we were building our own satellites right close to where I live in St. Henry. And we built the Alouette satellites, and we built the NASA Relay satellite in 1958. So among the first satellites, communication satellites being built in the world, we had the second geo synchronous communication satellite after SYNCHRON, built by HAC, Hughes Aircraft Company. We used to call it HAC. And we had the first, many firsts. So we've been always up there. We haven't had as big a budget as countries who are launching themselves, but we had many firsts. And I won't go through all of them, but we were always on the leading edge. Sometimes we had to pick which sector of space, but in robotics with the Canadarm, in a number of space communication and space radar with synthetic aperture radars, RadarSat. So we're continuing that trend of a space exploration, space first, or near first, being on the outer bubble that's expanding in terms of technology. But in the case of mining, Canada has always been the premier country in terms of mining. And if you look at even today, most of the mining transactions, financing, and all that, over 50% happen in Canada. And Canada is a very big country for mining. So Canada has always been extremely strong in mining and supporting mining. So now we have 2 areas which we've been extremely successful historically. We've been we've certainly been among the leaders, or the 1 or 2 leaders in the world in those fields, in both the mining field and the space field. So now in this kind of development sphere, or bubble, the sphere of development, we get to space mining, and it hits 2 of the resonant chords of Canada. One is novel space approach, and 2 is leadership in mining also. So we think that Canada is a good place for the Canadian Space Mining Corporation, but we are willing to partner with other countries that either are doing developments in space or doing developments in mining. And in fact, we just started a capstone project with or we're going to start one with a university in Sweden, with universities in Canada. And I would like to add one more thing, sort of parentheses here, is that university students and the brightest, keenest people there have always been a part of the space race and industry. Recently, we take many interns for stages in the summer or internships, but right at the start in 1958, we would have some of the brightest summer students. They would come from students that would come from an 8-month term with a 2-month overlap with the next replacement student, in order to get an input of fresh ideas and concepts. And just how thinking comes. You say, well, what about this and what about that, and sometimes it's good to have fresh new brains into this. So we're working quite hard with the universities, both locally and internationally. We've been talking to a number of countries about partnerships. So we're looking at it from an international point of view, but we do think that here in Canada is a good place to start because of our history in mining and in space.
Oh, that's incredible. Thank you for sharing that with us. Young minds bring fresh ideas. So
Absolutely, absolutely. And certainly that's a part of our development. Like not to you know, you have to have a proper dose of experience and fresh new ideas, and it's the mixture of both that kind of can lead to innovations and new things. You know.
yeah, absolutely. And a topic that I cover, in every episode is in terms of leadership. What do you think makes a great leader in the space industry?
Well, I think space industry is maybe too much in there. I think if somebody is a great leader, they can be a great leader in different industries. So I don't think that from that point of view, space is special from the leadership, but certainly it's somebody who can and see the forest for the trees kind of thing. Now, being able to go down to the tree level is useful also, but not staying there, seeing the big picture, and also the people aspect. The people aspect in terms of working with teams is one. Okay, when you're at the working level, people aspect in terms of constructing powerful, loyal teams that all share the visions you set forward, and that all share the goals, and to get that individual well, it's not so much commitment but dedication of the people towards that individual goal, to make it part of a common problem. And also, space and technology, but it's a people's game, as I was saying, for teams, and they have to work well, but also internationally when we work with people. I remember I signed a fairly important contract with it was Airbus Stevenage, and they had to supply some units for satellites, very like newer technology units, something that hasn't been done. So there's obviously always a developmental risk, and that's where many programs go wrong. But I knew the managing director over there, and we had a number of talks, and I got his personal commitment of him watching over this, and I knew the guy. But when we signed the contract, he said something that kind of stuck with me. He says, people think that contracts and work is between companies, but it's not between companies. It's between people. And it's those people that have good communication, that have trust in each other, that commit to each other, and you sign the contracts. And those have always been the most successful contracts that have led to new things and new generations. Contracts, sometimes they're set up for other or by other ways, and you don't have that contact between the people, and quite often that can lead to difficult situations. So this human connection, and this being, when I say getting the commitment from the other person, but in return you offer your commitment too. That kind of communication is also extremely important in achieving success and becoming what is called the leader. But you lead you lead by example, and you lead by giving a vision to your people, by working very hard towards that vision, and by treating people fairly and treating them like real persons, like not machines working on things, and understanding what what makes them tick, what makes you tick, and getting an understanding and moving forward. So I think that's important in becoming a leader.
I think that was an incredible response, and the first person that mentioned that a leader in any industry could be a leader in space, and you're absolutely right. And it is all about the people. So thank you very much for that.
It's a people thing.
Yep. So, who from the audience that's listening or watching to us would be the ideal person that you would want to contact you?
Well, we obviously looking for somebody who's keen, who's dedicated, somebody somebody who is willing to go into new area or newer areas, and understanding that we got to work kind of hard to sort out the mess of things that are out there and find the right things. He's got to be a team player. He's got to see the big picture. He has to be able to work in some parts of the detailed picture, and he has to be a keen person, obviously a smart person, but keen. You have people that are smart, but they're not keen. Well, that's, I'd rather keenness and a little bit less smartness than somebody who works hard. And genius is 10% genius, 90% work. But recognizing which is the right work to do, and that's where seeing the forest for the trees is, you can work really hard on some part of the thing, but it really doesn't help the whole thing. So you have to have that vision, and you have to be good, and you have to work in teams, and then we realign our visions together. But the kind of person we have is somebody who can work hard, somebody who's keen, somebody who can see the goal, somebody who can see what he's doing at the detail level is contributing to the maximum efficiency of getting to where we want to go. We say, well, yeah, I'll work a year on that and develop that, but it's not going to be that useful to do that. I had many people. I was, divisions leading R&D and leading developments and all that. And sometimes when I took over divisions and they weren't quite, I see them working so hard on some R&D project, but I say, but even if you're successful and develop that, it won't be useful. It won't be that useful. It's probably not going to be solved. It's going to work, but it's really neat, but it's going to be too expensive. It's going to be too bulky. It's not the right thing for the situation. Yep. So we can't be developing things like that. We have to be developing things that will be useful, so you have to have that vision, and you have to interact with the people around you and the people above you and below you to keep that vision going all the way through. And the communication skill are very important there.
Great. And how can they contact you?
Well, let's see. I had okay. There is a CSMC, Canadian Spice Mining Corporation website, and you can contact people at people at csmc-scms.ca. That's the SCMS is the French acronym for the Canadian Space Mining Corporation. We also have a Twitter account feed, which is twitter.com/CSMC_SCMS. And you can find our company on LinkedIn also. and it's, well, you can search on LinkedIn, but it's the Canadian Space Mining Corporation. So if you Google that, you'll hit it. So those are the way to reach it.
It was an incredible interview, Marc. It was an absolute pleasure and honor to have you here with us today. So thank you for joining us.
It was a good pleasure. By the way, behind me, what you see there, in case some people have been wondering, it's the wheel of the ExoMars rover, and it was quite a challenge. But I don't know if you see my finger. There's a one layer of springs there. That's kind of the shock absorber springs, and there's one layer of springs here because with the weight of the rover, it flattens and acts like tractor trailer threads. So yeah, it was on my desk in Toronto. So, all right. Thank you very much, and it was a pleasure for me to be able to talk and to communicate what is happening right now, and if I can be motivate somebody to go into that field, because now's the right time. So absolutely, this is the right time to be. 10 years ago, we didn't have the cheap launchers. We were far away from doing this, but now we're in that sort of 10-year-ish horizon where it's all going to happen and happen gradually, incrementally, and all that. But it is happening. It has started to happen, and we're at the right time.
Wonderful. Thank you, Marc.
Thank you.
All right, everyone. That was another episode of the Final Frontier podcast. I'm your host, Daniel Penaranda, and it was another great interview. If you liked it, please like it on YouTube, subscribe, follow us on all the different podcast platforms. We're available on Google Podcasts, Apple Podcasts, Spotify, you name it. And if you want to catch up on our previous episodes, you can also visit our website, thefinalfrontierpodcast.com. So I hope to catch you guys in the next one. You have a great day. Bye-bye.